When you drink from a straw, you are not actually sucking the liquid up the straw. What's happening is the liquid is being pushed into the straw. This happens because as you use the straw, the shape of your mouth changes. Your mouth actually inside, you increase its volume. When we increase volume, our pressure is going to go down. So the pressure inside my mouth goes down. It goes down lower than the atmospheric pressure. When this cup is just sitting here, there's atmospheric pressure, there's air pressure pushing on the surface of the water. When I change the shape of my mouth, the volume goes up, so the pressure goes down, and the pressure goes down lower than the atmospheric pressure. The atmospheric pressure then pushes on the water, and it pushes the water up into the straw and into your mouth. This is similar to the way a manometer works. So when we first have our flask and we have our hard-boiled egg, our egg does not fit into the flask. Regardless of how long we let it sit here, this egg will not go into the flask. But we can do something else. I take a wooden splint So now I have my wooden splint, and my wooden splint is on fire. I'm going to carefully drop it into my flask. Then I'm going to put my egg on top of my flask. Now, as you watch this, the flame grows yellow, and then it goes out. When the flame goes out, the egg goes into the flask. Now the question is why? While the flame was still lit, while the wooden splint was still lit, the temperature inside the flask was increasing. When our temperature increases, our pressure also increases. So the pressure inside the flask was increasing. When the flame goes out, the temperature inside the flask decreases, and it decreases fairly quickly. That decrease in temperature also causes a decrease in pressure. There is a seal around the top of the Erlenmeyer flask caused by the egg. The egg makes this nice seal around the top. When our pressure inside dropped because our temperature dropped, because our flame went away, our pressure ended up being lower inside the Erlenmeyer flask than the atmosphere. The atmosphere, the pressure we feel from all the air particles, then was able to push the egg inside the Erlenmeyer flask. So here I have a soda can that's sitting on a hot plate, and it's turned on, and it's been sitting here for a couple of minutes. There was originally a little bit of water in the bottom of the soda can, so now it's heating and it's been boiling. I can listen to it and I can hear the bubbles pop against the aluminum soda can. So what's going on inside the can? Well, we heated the water up, so the water particles are moving faster. Eventually they'll move so fast that the water particles will turn into gas state water particles. They'll go from a liquid to a gas and fill the can with gas state water. Now the pressure won't build because the top of the soda can is open. So really all I've done is I filled this can full of gas state water particles. What I'm going to do is I'm going to take it and I'm going to flip it upside down into this beaker of ice cold water. Now the question is, why did that happen? When we flipped the can upside down into the ice cold water, we decreased the temperature inside the can. That means a couple of things happened. One, the water particles in the gas state slowed down. They recondensed back into a liquid. When that happened, also due to the rapid decrease in temperature, there was a rapid decrease in pressure. That rapid decrease in pressure made the pressure low enough that the atmospheric pressure pushed onto the outside of the can. So science doesn't suck, it pushes. In the atmosphere, the atmospheric pressure pushed onto the outside of the can and made it collapse. Also, since we had a rapid decrease in pressure, it also meant that the atmospheric pressure was pushing more on the water in the beaker, causing it to go up and inside the can when the can collapsed.